Guys, let's get started. Yeah. So this week we're going to continue with DNS with our discussion of DNS, if you remember. Last week we looked at DNS client, right? And then some of the background, then we looked at DNS, configuring the DNS server. And we completed that. So everyone should go back to that video and make sure that you can set up your bind DNS server. So today what we're going to do is we're going to continue with that lab and just take a look at the different attacks related to DNS. And this is kind of to get a feel for how it works. Just essentially it's kind of looking at the packets in the background, etc. Next week is spring break, as you guys know, so we'll be off. And yeah, so that's exciting, right? So this week, my plan is to finish this homework assignment, this homework, and then it'll be due over the break. So I don't think you'll have any work over the break. I do recommend that you start thinking about the term project, for instance, form groups of 3 with your, find some classmates and start thinking of a topic. So the ideas are just configuring something in Linux, so configure something like an email server or do some scripting or things like that related to system administration. But you can start thinking about that. The presentations will be the week before finals, okay? Sheet of paper. All right, so this is week 9, right? So be aware of that. Think about it. That's really, we're getting very close to the end of the semester. It's week 9. Spring break is week 10. Then we're back in week 11. And the semester ends basically on week 15, 16, right? So we're getting very, very close to the end of the semester. We just have to wrap up a few of the topics, SNMP, Hadoop, and then just, more Linux commands essentially. But that's kind of the plan. Okay. So are there any questions before I get started? Also remember, week 12 is when your second exam would be. Okay. Questions? Yeah, go ahead, please. Yeah, you have to, the only way that I know it, right now, I keep track of what this week is. So this week is week 9. So we are currently on week 9, and the exam will be on week 12. I mean, it's everything. It's comprehensive. So it could be anything from the very first week until what we cover week 11. You can ask questions during that lab session. All right, so now I think that's everything out of the way. So let's go and take a look at the lab. Should be a fun lab, right? More complex, as you know, 2 virtual machines is a challenge. So let's take a look here. So I'm going to go to table of contents. And we're going to take, these are the topics we've covered. Host-based firewalls we finished, and then we are working through this one. I've been bad about giving you the Wireshark reading assignments. I'll start giving you some of those. They're very easy. All you have to do is kind of read through the document. There's some PCAP files that I posted on Brightspace, and you kind of just look at it, look at the case, etc. There's really no problem to solve. Today, use Wireshark, I recommend, on your virtual machine. And just so that the whole point is to understand how the packets work, right, when you're doing DNS. We're going to do the first problem, which is super easy. It's trivial almost. So we're going to take a look at that. Let's open the Word doc. And I'll start the virtual machine also, just so that it's going to go to VM. All right, so VM is running, starting up. Okay. So let's take a look at the Word doc. So we've gone over all these documents already. You know about these files. You should have used these files by now. Yeah, so the document is this. So you know this, there's anything that's available on the lab. We're just picking this. Bind, control this. Can refer back to the videos or read through the material. This was DNS client configuration. That's fine. This was DNS server configuration, configuring. That's done this last minute. Went over all this. And remember at the end, we do all this, do all that. And then you run this dig command, right? And you should get that your named server is the one that you designated, right? That's kind of, this is very abstract sometimes, but that's kind of how you know that you've done things correctly, right? You don't need to have Wi-Fi, or sorry, you don't need to have internet access at that point, but you do need to be able to try to resolve things through the DNS server. All right. All right. So now the fun part, right? So you guys want to learn about attacks. So we're going to learn a tool called netwox. We're not going to use Scapy to generate the attacks, although we could, but it would just make the lab too long. So, let's just do with netwox. So let's take a look at the first one. As you can see, the problems are going to be this one. This might be just the introduction. Yeah, this is the first problem, 3.1. Then we're going to do 3.2. And then finally, we're going to do 3.3. And that's it, right? So we'll stop at 3.3. That will be the last one that we do. All right, so let's take a look at the first one. And let's read through this first, right? So we're going to motivate this a little bit. So part 2, attacks on DNS. So remember, your architecture is a client-server architecture. You have a DNS client, one of the VMs, a DNS server, another one of the VMs. So this machine, okay, so this one, let me make sure I have these machines. Right, and I'll start the other one. So it's starting, I believe. Yeah, that's a good question. We'll be done with it for sure on Wednesday. I mean, I can make it after, so like it would be due 2 weeks from Wednesday if you guys are going on spring break or something like that. That's fine. Okay, so it's not a problem. But but it'll be. My plan is to finish it. I mean, we could finish today actually, but you guys have to solve some things, so probably Wednesday. All right, and then you guys go on spring break, and then when we come back, we'll do SNMP and Hadoop and kind of wrap up the semester. Keep in mind, they're like this one, right? This was the first one. This is the easiest. Hadoop is harder. They're just more Linux configuration, but by doing a hard project, you'll be a pro, right? So that's the idea. And so we'll talk about that one. So the VMs, I don't remember an issue with this, so I'll keep it small. right? All right, so let's take a look through it. So the main objective of DNS attacks on a user is to redirect the user to another machine, right? Um, another machine B. When the user tries to get to machine A using A's host name. So remember, it's all about the host name mapping to IP addresses. For example, when the user tries to access the online banking, if the adversaries can redirect the user to a malicious website that looks very much like the main website of the bank, right? So you type something like chase.com and it redirects you because it's going to do the name, the host name to IP resolution, and it just sends you to another server that looks a lot like Chase, but they're going to steal your connection. So obviously, there's things in the browser and things like that that would be alerts that that's happening, but the redirection part can still happen, right? And so you have to be aware of that. So if the adversaries can redirect a user to a malicious website that looks very much like the main website of the bank, the user might be fooled and give away a password of his or her online banking account. So that's the idea. When the user types sample.net in his or her browsers, the user's machine will issue a DNS query to find out the IP address of the website. That's exactly what we're trying to visualize, right? That's essentially the point. Attackers goes to fully use the machine with a fake DNS reply, which results the host name to a malicious IP address. There are several ways to launch such a DNS attack. So we can see figure 2 for the illustration of the attack surface, and you can read chapter 5 of the C-Lab book if you'd like. We will launch a series of DNS attacks on the example.net domain. It should be noted that we are using example.net as our target domain, not example.com. This latter one is already hosted by our local DNS server in the setup, so no DNS query will be sent out for hosting that domain. We can make up other domains as well in this. So that's kind of the introduction. So now, problem, right? So let's say set the first problem is super easy. When you just use something really important about it, and that's how Linux can do DNS resolution with the etc post file. So we're gonna play with that file today. All right, so this one started. Let me try to log in. So, all right, there we go. So finally, 2 VMs. All right, I'm gonna do the familiar thing. Just look at the IP addresses. So this is 202.15, and this is 10.0.2.4, right? So I got the 2 VMs. I'm gonna ping 10.0.2.15. All right, I can ping one machine from 10.0.2.4. Now I'm going to go to 15, and I'm going to ping 10.0.2.4. All right, and I can ping. So we should be good. All right, so now let's just read through the problem. So modifying the host file, right? So there is a file in the DNS configuration that says that when you're doing DNS resolution, there's a sequence to be followed. right? And the sequence is that you should check the etc host file first, right? And then after you've looked at the etc host file, which is this one, then you look at the bind DNS server for resolution. Okay, so you go here first. And that's a setting that you can change, but this is the default right now. So the host name, so this file, as you can see, is the etc folder where you have your configuration files. This is a file called host tied directly to DNS, and it'll just have entries. You can add any entry in there like this one, right? And essentially what it's going to do is it'll map that domain to that IP address. So a common example of this is, why does localhost work, right? So you guys know, you probably learned that all you have to do on a machine is type localhost and it redirects to that machine. How does it know that? It's because it says localhost and it's mapped to 127.0.0.1. So that's essentially the idea. All right. So in this very simple example, what we're going to do is we're going to assume that a hacker got into this computer and they have the root privilege and they can go in and change this file and add an entry in there for whatever they want. So that when you're in the browser and you type your domain, let's say my bank, let's use this example, bank32.com, it'll redirect you to the machine. And then we're just going to test that either with dig or ping or something like that. Do you guys see that? So that's essentially why I said this problem is so easy. So the host name and IP address pairs in the host file, which is this one, which you guys can see over there, are used for local lookup. They take the preference over the remote DNS lookups. For example, so here we're not using, everything is in the DNS client. We're not using DNS server at all. For example, if there is a following entry, in the host file, in the user's computer, the example.com will be resolved to 1, 2, 3, 4. So if this entry is in there, it'll result 1, 2, 3, 4. In the user's computer without asking any DNS server. Access example.com. Assume that you have already, now you assume here, of course, that you have already compromised a machine. So please try this technique to redirect bank32.com to any IP address that you choose. Okay. So essentially, it should be noted that etc host is ignored by the dig command, but this will take effect on the ping command and web browsers, etc. So compare the results and obtain screenshots before and after. All right, guys. So we're gonna do this one. Since 10.02.15 is DNS server, right? That's not where this attack should happen. Instead, this attack should happen on 10.024, which is the DNS client. So I'm gonna go to 10.024, the DNS client, and essentially it's bank32. So I'm gonna use this terminal and ping ping, and I'm going to do www.bank32. As you can see, nothing is happening. All right, as you guys can see, nothing is happening here. Right, so now let's add, so that's part of the screenshot. Now let's go into etc folder. So I'm going to do ls. So I'm going to actually clear it. So now I'm going to see hosts, right? And I just want to see permission. So this file is root on. I'm going to write to it. Only root can write, so we're going to have to do, So, and as you can see, the file a lot of entries for years. But the last entries for the last, so let's see, so shot a 32 million which is so 32 ABC 60 is and teacher yeah, so we don't actually have local host, right? It'll redirect to 10.0, oh, sorry, to 127.0.0.1, which is this machine. So now, essentially, we're going to add this entry, right? So I'm just going to remove the comment, and it is now there. So 1, 2, 3, 4, you've added that DNS resolution entry into the etc host file, and you can add as many as you want. Right? Very easy. So I'm going to hit Control X, Y, Enter. And now I'm going to try it again. I'm going to do ping. While it's not going anywhere, because there may not be this address, notice that it did resolve to 1, 2, 3, 4. Do you guys understand? So the part of etc host did work. The domain was mapped to 1, 2, 3, 4. Got it? Any questions on this one? I said it was very easy. So, all right. For the one thing I'm going to ask you, this is just for grading. For these problems, use a different IP for every problem. So, for instance, here I'm using 1, 2, 3, 4. So in the next one, you'll use something like 4, 5, 6, 7. And then in another one, you'll use 7, 6, 5, 4, something like that. That way, it's easier for me to, when I'm reading it, to make sense of what's going on. Got it? So just make a note of that. And I'll do the demos like that. But all right, that's the problem. See, it took like 10 minutes, right, to do. Any questions on etc hosts? All right, great. So that was the easiest one. The other ones are not so easy, but still pretty straightforward. So the next one, we are going to have to think, like of the scenario. So we have to it's an abstract problem, but we have to imagine it. So let's go over here. So we've done 3.1. You can add your results to your lab. Now we're going to do the next lab assignment. So the next one, task 5, 3.2, directly spoofing response to user. Remember sniff and spoof, right? From the SCAPI lab, it's essentially the same. And you could do this with it's SCAPI, of course, but that's a little bit more work. So instead, we're going to use something called netwox, which makes it a little bit easier. Netwox is a command line. It's a command on the command line that allows you to launch hundreds of network attacks. So these are only networking type of attacks. So imagine it's using SCAPI in the background, a library similar to that to craft packets that are consistent with network security. It doesn't include things like SQL injections per se. All right, so the scenario is here that we do have a DNS client and a DNS server. But in this, this is called directly spoofing response to user. So usually what would happen is the DNS client would get like, a host name. It wants to know the IP. It doesn't know it in etc host. So it'll query its DNS server. The DNS server then would reply with the answer, right? That's essentially what would happen. But in this scenario, we're going to assume that an attacker did a denial of service attack on the DNS server and took it down. So now all you have is the DNS client sending out the query into the network, and there's going to be a third computer, attacker, and attacker is sniffing the network, listening. It's going to capture that query of DNS, and it's going to spoof a response, okay? And it's going to send it to the DNS client. So, you could have 3 VMs, of course, and take down the DNS server. My suggestion is just you can just turn off the DNS server, right? So you can have it off and then just do the attack from DNS server. What I mean is turn off like the bind, essentially, right? So you can keep the machine on, but turn off bind and launch the attack from DNS server. DNS server just listening, and then when the DNS respond. Does that make sense, guys? That scenario? Okay. Got to do this, right? Pardon? All right. Okay. Well, yeah. So it's just that. I mean, you have 2 VMs, you're taking down the DNS server, and then there's an attacker, but in the interest of not having too many VMs, just use that same one. All right. So let's do this one. So you can see this at this is the local machines DNS client. So DNS client sends the DNS query to the DNS server. If the DNS server doesn't know, it's gonna have the or this attacker maybe launched a denial of service attack, so the machine is down. And so now when these clients issue the DNS query, its hackers listen because it's sniffing the network and captures the packet and is going to respond to the attacker. I would recommend this one turn on Wireshark and also so this little thing Wireshark so you guys can visualize. All right, this is my DNS client 10.0 024 024. All right. And then on over here, and we're going to turn off right. Pseudo service bind pseudo service bind stop. All right, so that's set up. Now the attacker will need to learn here. The tool is netwox. This is just a command line. You can also use something netwox like that. Should be like that, and that should launch GUI interface. So essentially, what you do is press the button, graph the attack, and then it gives you the command line entry, and then you just run that from the terminal. Okay? Either way, it's however you want to do it. I'm saying netwox, and it should be installed already. So yeah, you can see there essentially with the library to the attack. Clear here. netwox in the document. All right, so let's start reading through it. So now, go to, we have to think about this. How we're going to do so. In this attack, victims should not compromise. It's one of the nice things about security, right? So you have to take a course on network security. It's like whole family of that. Computer does not need to be like in a overflow act. And these types of attacks, you just crap packets. I mean, but crap packets that using the correct protocol still meant to fall the DNS the machine. So in this example, DNS client, no one hacks it, no one exploits the vulnerability. The only thing is, the DNS client, someone else, not the DNS, provides DNS response. That's still well crafted, it's just using the protocol. And for DNS. So that's a new family of attacks. So really interesting. Just explain the protocol. That's how we get this into it. And people put now just know. And so in this attack, the machine has not been compromised. So hackers cannot correctly change the process of the victim's machine. However, if hackers are the same local network, these are just local network, just members combined. There's DNS remote that you guys can read on the Seed Labs website. However, if attackers are on the same local network as the victim, they can still achieve great damage. Okay, so when a user types the name of a website, a host name such as example.net or bank32.com in a web browser, the user's computer will issue a DNS request to the DNS server to resolve the IP address of the host name. After hearing this DNS request, the attackers can spoof, and you guys know how to do that already with Scapy. The attackers can spoof a fake DNS response. The fake DNS response will be accepted by the user's computer if it meets the following criteria. So this is where, it's not a vulnerability, but it's still somewhat difficult because you have to have certain information, right? So you have to know how the protocol works. So you have to have the source IP. So the source IP address must match the IP address of the DNS server. The destination IP address must match the IP address of the user's machine. The source port number, UDP port, must match with the port number that the DNS request was sent to, usually port 53. The destination port number must match the port number that the DNS request was sent from. So that's why, for instance, for this entry here, sniffing is very important. You have to sniff that packet, capture it, copy it, and then modify it. So this is what, when we did Scapy, that was pretty relevant to this. The UDP checksum must be correctly calculated. The transaction ID must match the transaction ID in the DNS request. The domain name in the question section of the reply must match the domain name in the question section of the request. The domain name in the answer section must match the domain name in the question section of the DNS request. The user's computer must receive the attacker's DNS reply before it receives the legitimate DNS response. So this is important. It creates something called like a race condition when two threads are moving, and competing with each other to see which one arrives faster. Actually here, Python has a disadvantage because it's a little bit slower, like imperceptible to humans, but on the computer, it is actually slower. So for these types of attacks, it's always better to launch via C. C++ is more efficient and faster on the network. So this is another reason why netwox is good, because netwox is compiled in C, so it's faster. If you this it's a little bit slower, and sometimes it's the correct entry arrives first. Let's call it a non-attack entry. But anyway, that's an important point. All right, so we should get to this work just fine. So to satisfy criteria, 1 to 8, the attacker can sniff the DNS for a message sent by the victim and just copy it. So that's, like I said, that's pretty straightforward. They can then create a fake DNS response and send it back to the victim before the real DNS server does. So if you guys don't turn off the DNS server, you're racing against the DNS server. See the effect. All right. Netwox tool, so that's what we're using, has the command 105, so 307, and whatever. Those are different types of network attacks. So in this case, we're doing Netwox 105, which relates to DNS attacks. Okay, sniff and send DNS answers. So Netwox 105 provides a utility to conduct such a sniffing and response type of attack. We can make up any answer. We can use the filter focus. Using something like sort post and to 4 in this case, for me. But that would be a good filter. So capture just those packs, sniff them, copy them, modify them, and go back out. Does that make sense? Yes. That's it. All right, so we can list over the manual was described as screenshot. So we can see it. So it's basically a sniff and send DNS. Standard usage is going to be network, and then we provide these fields, all of this, and then we specify IPs if we want impact. And then there's a structure here for the parameters, name, host name IP, target name server, target SIP, APCL, filter, IP spoofing, and so on. So these parameters that made a little bit down. The attack program is running. You run the command on behalf of the user. Commanders the user machine to send DNS query to the local DNS server. That just send out a DNS query to the name server of the selected domain. If the container your packet successfully should be able to see information in comparing results before and after. And that's essentially it. And so here on answer before, we're going to something like take bank 32 right. So that's the idea. Do something like that. We're that whole thing. The DNS query, the DNS or the DNS or but the attacker is going to respond. And you guys are looking at this mark. So now let's go here and let's start thinking about crafting. Now, one thing I have to make sure, this is why I recommend that you use different IP, but go back to that EPC host file and remove this thing, right? Because otherwise, it will provide a response from for the entity, right? Because you have it, so you get confused. Two mechanisms to avoid this problem. Comment this one out. For every problem, use a different IP address. That was possible. Right? So let's try a 10.0.2 www bank 32.com. Nothing should happen. This is on the bottom here. And you can see they also didn't work the first step. So now we need to go to the attacker machine and launch the attack. So that's going to be, you need to do sudo here, just like with SCAPI, because you need to have access to the network interface. So you're going to do sudo netwox. Right, and then 105, which is the attack that we're doing. And then you have to put in .h. So this should be the domain. So let's try www.bank32.com. And then we want the IP to be returned. So let's say 4.5.6.7, double quotes. Then we're going to do .a, then .a should be the names. This would be the name circle. So I'm going to do ns.sample.com, which is the domain figure, right? And the address for that, which should be 10.0.2.15. And put that in the equals. The network interface -p. These interfaces are, I believe, EN. Can you look it up? Can somebody look it up? EN E0S3. And then filter. So -f. So in this case, we're going to say source host. And this is the DNS line, right? So that's, if you got it right, you play with it to try to figure it out, but hopefully that's correct. It's sniffing in the network right now, if you look. Does it make sense? So information, if it catches a DNS query, it's going to copy it, loop it, impersonating a DNS server. C question. Right? So you just have to do this on your own machine. Okay? So coordinating with users. And then providing enough evidence such as this screenshot that we got. Got it? Right. So that's completion of the second prompt, and now we just have the third one. So I'm going to go ahead and hit save here. I'm going to kill the attack here. Right. So now we need to restart bind because the third problem does require bind to be run. So this time around, we're not just going to pretend to be a DNS server. We're going to attack the DNS server in particular the attack. And we're going to add an entry in it that will provide the resolution. So, it should be, yeah. The student service bind and restart. It restarted. And you can see we are getting a response 101, which is coming from our DNS server, which is essentially our bind server is now up and running once again. And then bind and then server, both of those are now up and running. Right? So no denial of service is back. So, here for this one, I'm going to list the attack actually from DNS client. Obviously, we would have a third VM that would do the attack, but just in the interest of saving memory, we're just going to have DNS client and DNS server. And I'm going to run the attack for one terminal on DNS client. Server me. So, Great. When Apollo gets at the answer, it will store the answer in the cache. So next time there is no need to ask other DNS servers. All right, so therefore, attackers can spoof the response from other DNS servers. Apollo will keep the spoof response in its cache for a certain period of time. So that's the objective. Got it? Next time, when a user's machine wants to resolve the same spoof, the same code name, Apollo will use the spoof response in the cache to reply. This way, I only need to spoof once, and the impact will last until the cache information expires. This attack is called the DNS attack poisoning. It's the same networks for this attack, just with different fields. Make sure that it serves as M. So we're going to do that. Of 10.0.215. The command sudo r and between this attack and the previous attack is so we set up the filter field to source code and then this the client the fake in the DNS server. Uh, Let's take a look at, so I'm going to run the attack from here, netwox, sudo, netwox, right? So far, but also let's try ping or let's try ping first. So I'm going to do ping, what is it, bang32.com. I'm going to wait to see. Remember, I'm going to use an IP 78978. Let's use 66789. Right, with reversals. All right, so no response here. I'm going to use gig. It does. Correct. Zero. No. So no. That two, no five. Understand a little bit how this would work, right? So the DNS client and make it to the DNS system. DNS server gets the query request, does not know the answer. Then what does the DNS server do? It issues DNS part in the web. That's where the attacker then ended. That doesn't give me much information. I can see it's got bang 32 in it. DNS answer. Let's go to DNS server. And in the PDF, it says something about to dump and view. The entries to see if we added it, if we're looking for that IP address. We're gonna try the following commands. Sudo rndc dump d hash. Then we're gonna do sudo Right. So one thing I'm thinking about is let's go back to the command. So here, imagine that let's kind of like reason through this one, right? So you're the attacker. You get this query from 10.02.15. It's the only thing that I can think of is that maybe this should be 10.02.15 here. We'll have to let's read the documentation of the fields here, right? So it says, um, dash little h host name, okay, that uppercase H host name IP that, you know. So this A1 is authoritative name server, authoritative IP. Device, TTL, filter. So what I'm going to try, instead of the Google one, I'm going to try the actual 10.02.15. Let's see if that changes anything. So it would be here example.com. And this, of course, would be 10.02.15. You guys see that? Okay, so that's running. My answer. Something did go out. DNS answer says bank 32, but it's not providing the IP. Big bank 32. My answer. So, uh, well, that's what we have to solve. All right, so we've got that's the instructions. We read through all this. It says here that the difference between this attack and the previous attack is that we are spoofing the response to DNS server now. So we set the filter field to source host 192.168.0.10, which is the IP address of the DNS server. Yeah, so that's so that has to be 10.02.15. Right, so that's the logic there. Yeah, so it's gotta be The only thing we can try here is 10.0.2.4, but I believe it's 10.0.2.15. ENP 0S3. www.bank32.com 9876. And that's example. Any ideas? Got to solve this one. It's the last one. We're almost there. Server's running. If I change this to 10.0.2.4, then it's listening to this machine, which so you can see the query just went out. There's the 9876 for this one. So we got that. 9876. So that works. If I do dig, you can see it provides all the information. But that's not what the problem says, right? The problem says to use in the filter. The source host should be querying something. Do you guys see the difference? Right. So here it's listening directly to DNS client. It did everything just fine. See it. It'll provide the resolution in a second. There it is, 9876. But the attack, they're both listening. But it says that this should be 10.0.2.15. Bank 32.976. It's there. Yeah. All right. So, do you guys get it? So there's a diff. So obviously I get it if I just change that filter to the DNS client. However, the problem does say that we should do it, that it should be a query coming from DNS server. So, work on it. Okay. And see if you can figure it out by Wednesday. And we'll pick up from here on Wednesday. So you've got the command, you've got everything. You just have to play with those fields a little bit. Does that make sense? That's the last problem. And we just need to wrap our brains around it. I feel like something is off, but anyway. So I am going to stop the recording here.